They were watching when dust refused to behave. If the green glow under the eclipse was the first anomaly, the second came when scientists studied how Atlas scattered light. Comets usually follow a predictable script here. Their dust reflects sunlight in certain ways, creating patterns we've seen hundreds of times. But Atlas didn't play along. Polarimetric measurements, basically studies of how light is polarized when it bounces off dust, showed something no one expected. Atlas displayed an unusually deep and narrow negative polarization branch. At a small angle to the Sun, the numbers plunged to about -2.7%. Then at around 17 degrees, the signal flipped again. For non-specialists, that might sound like technical noise, but in comet science, this is huge. No known comet or asteroid in the solar system has shown this exact behavior. Normally, the light curve is smooth, predictable. Atlas's was sharp, exaggerated, almost like a spike in a signal. What could cause it? One idea is that Atlas's dust grains are built differently, maybe larger, maybe structured in a way that bends light in unusual patterns. Another possibility is that the dust is coated in ices or compounds we rarely see near our Sun. Whatever the case, the result was the same: light that looked distorted, carrying a signature we couldn't immediately explain. That's why some astronomers described it as if the comet's dust was talking back. The sunlight didn't just bounce off Atlas. It came back twisted, carrying information. To some, it looked almost like a coded fragment inside the transmission. This was the second clear anomaly. First, the unexpected color. Now, dust scattering that didn't follow the rule. Atlas wasn't simply glowing and shedding material like every other comet. It was showing us line by line that its transmission would be harder to read than anyone thought. Water where the Sun cannot reach. If Atlas had stopped at strange colors and dust, it would already be remarkable. But another anomaly arrived when astronomers turned ultraviolet eyes on it. Using NASA's Swift Observatory, they detected something comets shouldn't show at that distance: water activity. Normally, comets begin releasing water when they're much closer to the Sun, within 2 astronomical units or so, where the heat is strong enough to melt ice into vapor. Atlas, however, was still out at about 3.5 astronomical units, farther than Mars, where the solar warmth is weak. And yet, the data revealed clear signs of hydroxyl, OH, molecules, the unmistakable proxy for water. The numbers were hard to ignore. Atlas was producing water at a rate of roughly 1.35 times 10 squared molecules per second, about 40 kilograms of water every second. At that distance, a typical comet would still be asleep, frozen solid. But Atlas was already awake, venting like something carrying its own internal heat or a chemistry primed to break the rule. What made it even stranger was how steady the release appeared. It wasn't a sudden flare-up or a random spike. The activity was consistent, as if Atlas had a hidden reservoir of water ready to bleed off long before solar heating should have triggered it. That's not how comets behave in our system. Water waits until the Sun calls it out. Atlas seemed to act on its own schedule. This was the third fragment of its transmission: first the green glow, then dust scattering like a coded signal, and now water appearing in the cold outer reaches where no water should yet flow. Atlas was telling us something through its chemistry. Whatever star system it was born in, the rules of formation weren't the same as ours. In one quiet ultraviolet observation, we got proof that Atlas carried the fingerprints of a different Sunday. And that fingerprint was written in vapor, the tail that pointed the wrong way. Every comet has a tail, and every tail has a rule: it points away from the Sun radiation pressure, and the solar wind push dust and gas outward, carving that familiar streak across the sky. It's one of the simplest, most predictable parts of comet science. But Atlas chose not to follow it. When the Hubble Space Telescope turned its eye toward the visitor, astronomers noticed something unusual. Along with the main tail stretching outward as expected, Atlas displayed a sunward extension of brightness and antitail. Instead of material blowing away, some part of its coma seemed to stretch toward the Sun. At first, it looked like an imaging trick, but repeated exposures confirmed it. There was real asymmetry in the glow. The effect was faint yet striking. Where comets are supposed to trail neatly like streamers in the solar wind, Atlas looked messy, almost defiant. What could cause such a thing? One idea is that large fragments of ice and dust ejected from the nucleus weren't pushed as easily by radiation pressure and instead lingered in odd configurations, creating the illusion of a sun-pointing streak. Another suggestion is that Atlas's dust grains are unusually reflective or structured, bending the light in ways our models don't normally account for. Whatever the reason, the image itself was unforgettable, a comet breaking the most basic rule of comet behavior. A tail that didn't just point away from the fire, but reached toward it. Atlas wasn't simply passing through our solar system. It was rewriting the visuals of what a comet can look like. And the antitail was the boldest reminder yet. This object wasn't here to play by our sun's rule. A heartbeat written in red. Most comets flicker with activity, but Atlas began to show something more rhythmic, almost like a pulse, as astronomers tracked it through July and August 2025. Careful photometry revealed a rotation period of about 16.16 hours. That's not extraordinary on its own, but what stood out was how the comet's brightness and color shifted with that cycle, like a repeating beat in its signal. The dust output, for instance, wasn't dramatic. Calculations put the rate at only 0.3 to 4.2 kilograms per second, modest by comet standards. But it wasn't steady either. Some phases of rotation released more, some less, creating a pattern that suggested the nucleus wasn't uniform. Atlas wasn't venting evenly. It was patchy, as if one side carried reservoirs that the other side lacked. Then there was the color. Over the course of the summer, Atlas's hue gradually reddened. To the eye, it was still faint, but instruments caught the change. Comets from our system sometimes redden as dust builds or surface material alters under sunlight. But Atlas's rate was faster, sharper. That raised questions. Was its dust coated in compounds that darkened